So, as I told you in the last video, before proceeding with the chapter 2 of structure and interpretation of computer programs, I want to do a small recap of the main of those that I think are the main takeaways from chapter 1. Chapter 1 is titled Building Abstractions with Procedures. And if you think about that chapter, you realize that chapter 1 is not really about learning a programming language, even if Scheme, which is a dialect of Lisp, is introduced. It's about learning a way of thinking. And so the title itself is the lesson, Building Abstractions with Procedures. It's not writing code, it's not learning the syntax of a new programming language, but building abstractions, which is probably one of the deepest ideas in computer science, because abstraction is really a tool for managing complexity. Indeed, we can start with extremely simple things. So, for example, numbers, arithmetic, procedure definitions, but something important is already happening. Indeed, we are taking a process and we are giving it a name. And once we give a name to something, this thing becomes reusable, composable, discussable, and mentally compressible. We can say that without abstraction, systems become impossible to reason about. And in particular, a procedure is an abstraction over a process. And computation becomes the evaluation of symbolic expressions, and this shifts programming much closer to mathematics and logic than to machinery and hardware. The computer indeed becomes almost secondary, and the real object of study is the process. Two procedures may compute the same mathematical function while generating completely different computational processes, one growing and one flat. And in particular, in chapter 1, we saw that we can have a recursive process with growing memory, deferred operations, and increasing complexity. You should remember the tree recursion, for example. And we also can have iterative process. An iterative process with fixed state, constant memory, and stable resource usage. So, in a sense, we can remark that computer science is not only about correctness, but it's also about time, memory, and process structure. And that's why complexity analysis is introduced. The concept of recursion itself is fascinating because we have basically finite rules, but we can have with these finite rules a very complex behavior. Indeed, recursion allows a problem to be expressed in terms of a smaller version of itself, and this idea appears everywhere: mathematics, and computer science algorithms, fractals, and probably even in human reasoning. And what makes this concept so powerful is the gap between the simplicity of the rule and the richness of what it generates. And Finally, the last paragraph of chapter 1 is about abstractions over abstractions. And in a sense, this is the moment where the book truly changes level. Because procedures are no longer just tools to compute numbers, procedures themselves become manipulable objects. A procedure can receive procedures as arguments, can return procedures, and can describe computational patterns abstractly. So the details of a procedures become parameters. How to transform values, how to move through a sequence, when to stop. And if you think a bit, if you think about this, you should realize that modern software engineering, modern software development is built exactly like this layer of abstractions operating on other abstractions. As I mentioned before, chapter 1 introduced also the topic of complexity analysis, and we have seen that small structural differences might have enormous consequences at scale. And in chapter 1 is shown repeatedly that the shape of a process, and not just the fact that the process is correct, is what matters when inputs grow large. And we have seen linear growth, which is proportional to the input size, constant growth, logarithmic growth, and exponential growth that quickly becomes difficult to compute, or at least very, very slow. And the fact is that at a small scale, many approaches appear to be equivalent. So for a small n, you can really perceive the difference between a linear approach, a linear algorithm, or a logarithmic algorithm or exponential algorithm. However, at large scale, as n grows larger, the structure dominates everything, and you really can perceive the difference in time and space complexity of two different algorithms. And of course, this principle extends far beyond programming, and you can find it in organizations, infrastructures, learning systems, habits, training. You mention it. Basically, if there is complexity, you can find these concepts. So, chapter 1, and at this point, I think the entire book is not about coding, but it's about symbolic reasoning. And the book treats programming as symbolic reasoning, of course, the design of abstractions, the engineering of a process, and the management of complexity. So if you take all these 4 points, reasoning, abstractions, process engineering, and complexity management, you realize that computer is a medium for thought, is a tool to think. And probably this is why this book still feels modern after decades from the first publication in 1984. Because this book is teaching ideas that are much deeper than any book about a specific technology stack or a specific programming language. So in a sense, we can end this video and end the recap the recap of the chapter 1 with this sentence: the true power of computer science does not come from hardware, because hardware scales computation, but abstraction scales cognition. And I really agree. I really agree on the fact that programming is essentially a technology, a tool for thought. So, just to summarize, 6 ideas from chapter 1, because chapter 1 is, there is a lot of mathematics, there are a lot of exercises, it's all the examples are made are based on numerical data. So you have these exercises and these examples in number theory. But if you strip off all the mathematics, what you are left with are these 6 ideas: abstractions, and the fact that naming things makes them reusable, composable, and mentally compressible. The difference between procedures and processes. So the process is what evolves, and the procedure is more a pattern. The difference between a recursive process and an iterative process, you can have the same results, but completely different shapes and complexity. Then we have been introduced to recursion, where with finite rules we can generate very complex behaviors, and also to asymptotic thinking, when you can see that at scale structure dominates everything. And finally, higher order procedures, that is abstraction over abstractions, that is where things start to become very interesting. So I'm excited to continue to read this book, and see you in the next video. Ciao ciao!